Welcome back to my channel, everyone. Sri Tips here, and what we've got here is some gold bars that I've kind of been saving up from recent video refinings. And let's see what we got here. 164.7 grams of high purity gold that we're gonna do a repurification on. We're gonna produce some high purity gold powder slash sponge from these gold ingots. And to get high purity gold powder, what we want to do is start with some high purity gold ingots. So I'm just going to place these in this 4-liter beaker. Now what we'll do, got a clean stir bar here. Put that in our beaker. And I'm going to add in about 1,200 milliliters of hydrochloric acid. The gold looks pretty sitting in that acid. Notice how it doesn't react at all with just hydrochloric acid. What we're going to do now is stick this up on our stir plate up here. I'm going to cover this up. I'm going to turn on a little bit of heat and start heating this up and start the stir bar going real slow. I've got a separatory funnel set up as a delivery funnel. And what we're going to do now, I've got some nitric acid in this graduated cylinder. It's about 170 milliliters. I'm going to add this right into our separatory funnel now. Now we're going to add the nitric acid delivery device carefully here into our apparatus. Now we're going to start a flow of acid down into our gold with hydrochloric acid in it. And we're going to go ahead and dissolve this now, slowly. We started this at 2 p.m. The time right now is 6 p.m. and I've got just 2 chunks of gold left in there. 3 of the bars have dissolved completely, and I'm not gonna add any more nitric acid. I've added another 75 milliliters of nitric acid for a total of, what would that be, about 250 milliliters of nitric altogether. And so now what we're going to do is just let this boil until all of the fumes go away. And I'll probably still have a little bit of gold in there, but that's what I want to see. And that'll guarantee that we've used up all of the available nitric acid so that we don't have excess nitric acid for the next step. All 5 of the bars have dissolved, and I knew I was in trouble when I came out and I seen the fumes in the beaker there. So I added a small 4-gram bead of pure gold that I had set aside, and it too has now dissolved. This has been on boiling now for about 9 hours. It's reduced down below 750 milliliters of solution. So I've got about 8 troy ounces of gold dissolved in less than 750 milliliters of solution. I've got a Panda coin here, this 999 fine. I wanted to measure it and make sure we got the real deal. It's got the right specifications, the weight, and the size of the coin, so we can conclude safely that this is going to be pure gold. Alright, the reason I weighed this coin and measured it is to be sure that we've got pure gold here. And it checks out. So what I'm going to do now, what I did is I added too much nitric in here for the sake of speed to try to capture the gold bars dissolving on the time-lapse video. And probably 200 milliliters should have done it for those 5 bars of gold, but I added an extra 50 to get them to go into solution quickly, and now I got a whole bunch of excess nitric. So we're going to put this down in here now and dissolve this and use up the rest of the nitric acid that's in there by dissolving that Panda coin in our solution. Again, what I'm trying to do here is consume all of the excess nitric that's in that solution. That's why I added the coin. My goal here is to have all those fumes clear up inside the beaker and have just a small sliver of that gold coin left in there once the reaction is complete. And that's how I will be able to tell that all of the available free nitric has been consumed. Now that Panda is completely gone. It took about 20 minutes and it's completely dissolved. So now we're going to add another 10-gram bar here. And hopefully this will do it for us. Alright, we're looking in better shape now. There's the coin back there, or the bar. It's still present, so that means we're slowly but surely consuming the excess nitric in here. I've got the liquid level down below 500 milliliters. So we now have about 8 troy ounces of pure gold dissolved in less than 500 milliliters of solution. This has been on boiling now for about 11 hours. Okay, we've been at this about 14 hours now. There's our bar of gold. You can see in there it's remaining undissolved, and that's what we want to see. All the fumes have disappeared in there. If you look, we've only got about 250 milliliters of liquid. Okay, I added 4 plus 7.4 plus 10. So I added 21.4 grams, and we had 264.7 when we started. That's 286.1 grams of pure gold. Divide that by 31.1. So we've got over 9 ounces of pure gold in 250 milliliters of solution. I've got some hydrochloric acid here, and what we're going to do is I'm going to rehydrate our solution here. Let's see what happens. I'm going to add hydrochloric acid in. If we see a bunch of fumes forming, which I do not see, then that would indicate that we're expelling excess nitric acid. And I don't see that. So I think we're in pretty good shape here. We've got all the excess nitric expelled from our solution. I think we're done with dissolving our gold. I'm going to take it down off the heat now. Ooh, that thing feels heavy for just that little bit of liquid. Everybody was asking if the liquid feels heavier. Look at that bar of gold half dissolved in there. Everybody was asking if it feels heavier with the gold in it, and it does feel a little heavier than it normally would if that was just liquid with no gold in it. I'm going to add about 250 milliliters of hydrochloric here, get it back up to 500 milliliters. I've added a few ice cubes to cool our solution down. Now what we're going to do is filter it right quick here. I did allow it to cool down to room temperature before I added the ice, and the ice cubes are made from distilled water. So now we're going to pour it through a filter here. Here we go. Let's see if we can take a look at this little piece of gold here. It's just a very thin wafer of gold that was left over after we used it to dissolve or to consume the excess nitric in our gold solution. Here's what our filter looks like. Nice and clean. Nothing was really pulled out of the solution. No contamination to speak of. So what we're going to do is we're going to take the funnel off of here now. Alright, this is definitely going to crank out some heat. So I'm going to add some ice, precipitating out this solution. This much gold is going to create a lot of heat, so the ice is made from distilled water. Let's go ahead and trade these two. I'm going to add the gold solution now to the beaker. See that you can see the two different densities of liquid. This is high purity gold. I can tell by how clear this solution is. Let's go ahead and pour it in now. we're all set up. And what we're going to do is use sodium metabisulfite, aka SMB. And now we're going to precipitate out our pure gold. Alright, for the benefit of those who've never seen it before, I've got a little bit of the solution on a piece of filter paper. And now what I'm going to do is I'm going to use some Stannous chloride testing solution. Test for the presence of gold. We'll see a dark stain if we got gold in solution. Just like that. Now we're going to see if that denoxing worked or not. Here we go. First spoon of SMB going in. Two. Three. Four. Five. Six. Seven. Eight. Nine. And 10. Yeah, you can definitely see a layer of gold down here. It's kind of warm. I'm going to go ahead and give this a swirl to stir this up a little bit. You'll see it turn back to yellow, which means we still have gold in solution. Alright, I'm going to reach in here and get a little on the filter paper. I'm going to test it again. Looks like we've still got gold in solution from that yellow color. We've got lots of gold in solution. It's a black stain. Alright, let's see what we got in here. Oh Lord, we got a ton of gold powder in here. I'm going to add another spoon of SMB. Put it right on in. Here we go. I'm going to add another one. This is number 12. I think it's going to take about 20 spoons. This is number 13. 14. See, it's still looking yellow. 15. 16. 17 spoons of SMB so far. Wow. 18. 19. I think we're getting pretty close. And there's 20. I'm going to give this a stir. Looks like we might have all precipitated out now. I've allowed the gold to settle. And what we're going to do now is get in here and pour off the waste solution into our temporary waste container. Here we go. And here's a look at the gold down in the bottom of the beaker. I'm adding some distilled water, and we'll rinse the gold off now. Multiple times with some distilled water, get all the excess SMB off of here. When working with this much gold, some of it wants to go back in solution sometimes. And I've seen a little bit of a yellow color, but now it's turned purple. And we're going to pour this off into our waste container. Any gold that was in solution or that gets poured off with these rinses, we'll recover it out of our waste container here. There you can see some yellow gold in solution. I have this happen whenever I work with large amounts of gold like this. Some of it wants to try to go back into solution. See that? Alright, I'm going to add a little scoop of SMB here and see if what kind of effect this has on it. That's bizarre, man. The gold is coming out of solution. Man, that's weird looking. I'm not used to working with large amounts of gold like this and see some strange things with it sometimes. All right, let's pour this off now. Starting to look pretty good now. This is more like what I'm used to seeing here. I'm going to add some hydrochloric acid, also known as muriatic acid. I'm going to rinse with a little bit of hydrochloric acid now. Alright, I'm going to pour this acid rinse off now. Gold is looking fantastic. I'm going to add a little hydrochloric acid to this. I'm going to set it up on the heat. And we're going to do a quick boil in hydrochloric acid. It's been on there boiling for about 10 minutes now. So what we'll do is we'll reach back in here. Let's pull this down off the heat. Oh yeah, that gold is looking spectacular. I'm gonna reach in here and pour off this hydrochloric acid boil now. I've got gloves on because this beaker is too hot to handle with just nitrile gloves. Rinse with a little water. Let's see how this is. Still pretty warm. It's looking real good, man. That's perfect. I've got the gold all rinsed off. Now we're going to dissolve it a second time. But instead of using aqua regia, I'm going to use 29% hydrogen peroxide. So I'm going to fill this funnel up with our 29% hydrogen peroxide. I'm adding hydrochloric acid to the gold now. People have asked, why are you calling it hydrochloric acid when it says muriatic acid? And the reason is muriatic acid and hydrochloric acid are one in the same. So now what we're going to do is add about 1 liter of hydrochloric acid to our gold. Set it up here and start feeding in our hydrogen peroxide to dissolve the gold a second time. I'm adding some heat, and now what we'll do is start the flow of our hydrogen peroxide down into the beaker. It's taken 3 hours and I've probably got 70% of the gold dissolved. So what I'm going to do now is add some more hydrochloric acid, some fresh acid. It's about 150 milliliters. I'm going to pour this right on in. Now we're going to add some more 29% hydrogen peroxide. I'm going to measure out about 100 milliliters into my beaker here. And what we'll do is just go ahead and start adding this in now, a little bit at a time. See if we can get the rest of this gold to dissolve. I produced a fairly vigorous reaction. Got to watch out how we add this stuff. Don't want to create a boil over. What we'll do is, instead of pouring it in like that, I'll add it a little at a time with a dropper until we get the rest of the gold to go back into solution. I've got just a few little crumbs left in here. I've added another 150 milliliters of hydrochloric acid. I'm going to shoot in a little bit more of this hydrogen peroxide. I'm going to try to get those last few crumbs of gold to dissolve for us. It is now 12:30 and we've had this on for about 5.5 hours. I've got everything to go into solution now. We're going to pull it down off the heat and we're going to let this cool down now, and we're going to go from here. Alright, we're going to use copperas for part of the precipitation. Up here you'll notice that it says 1 pound of green copperas for each 50 pennyweight of gold that you expect. 20 pennyweight is 1 ounce, so 50 pennyweight will be 2.5 troy ounces. The name of the book is Refining Precious Metal Wastes by C.M. Hoke. So what we'll do here is I'm going to measure out. I'm going to go with about, I guess, 2.5 pounds, which should be roughly about 1 kilo of iron sulfate, copperas. So we're going to measure that out into our beaker here. Wow. Alright, there we go. Alright, I've got 1,075 grams of copperas. I'm going to add some distilled water to a large beaker now. Now we're going to put this up on some heat and start dissolving our copperas. Just going to start adding it right into the water and start dissolving the copperas. The advantage of using copperas over other precipitants is copperas will precipitate only the gold. So if we've got anything else in solution with our gold, it will stay in solution and only the gold will precipitate when we use copperas. Alright, the negative aspect of using copperas to precipitate our gold is that it takes a lot longer because we got to dissolve the copperas and filter it before we can use it. I'm adding a little bit of hydrochloric acid to our copperas, aka iron sulfate, aka ferrous sulfate. That'll turn it green. While we wait for the copperas to dissolve, I'm going to put some ice into the gold solution here. It's been allowed to cool down for a little bit, but we're going to cool it down some more with some ice made from distilled water. Now we're going to reach back here, grab our copperas solution, and we're going to pour that into a filter now and filter out this solution so we can add it to the gold and precipitate our pure gold. I'm filtering the copperas that I dissolved. And while we're waiting for that, what I'm going to do is reach back in here and I'm going to divide the amount of gold that we have in this flask. We're going to divide it up into 2 beakers. We're going to set this one back out of the way. And we're going to bring this one up now. And what we'll do is we're going to do a precipitation on this one with some SMB. Here we go. I've got SMB in this container right here. And what we're going to do is add some spoons of it and precipitate out the gold in this container. Finally got all the copperas filtered. And so now what we'll do is we're going to rearrange our containers here. I'm going to need to transfer this solution here into a large beaker, because I've got to add a whole bunch of copperas to this to get it to precipitate the gold. Alright, here we go. We're going to add the copperas that we filtered to our gold solution here. Let's get set up to see how this is going to do. I'm not exactly sure how this is going to look, but now I'm going to add the filtered copper solution here into our gold. I'm just going to add it right on in. Here we go. Here we go. Alright, I'm going to give this a stir. I just hope this was enough ferrous sulfate to precipitate all the gold. Let's see what we got for a Stannous test here. Looks like we might. I can't really tell there. I've got a little bit of solids on there, but I don't see a whole bunch of gold in solution left, so I think we've got it all dropped. Let's do another Stannous test. I think we've got it all. I just want to make sure here. The yellow color there can be deceiving because ferrous sulfate is yellow. And that Stannous test is definitely negative. So all the gold has been precipitated. I've got the gold split equally between these two beakers. This is the one we just precipitated with SMB. And now what I'll do is I'm just going to pour off the waste solution here, get rid of the waste solution into my temporary waste container. And any portion of gold that gets poured over with this will end up in the waste container, and we can recover it later. This off with some water. There's a ton of gold in here. Here's a look at the gold. Now let's take this over to the melt table, and we're going to start melting this up, a chunk of gold here. Here's our nice pure gold bar. Good Lord, look at that thing, man. It's just beautiful. High purity, triple refined, pure gold. Let's see what we got for a weight on this one. We've got 148.3. That's 4.7 troy ounces of pure gold. We're going to turn our attention now to the gold that we precipitated with the ferrous sulfate. I've got my stock pot here, one of them. And so what we're going to do is we're just going to add the waste solution. This is ferrous sulfate. We're going to put the waste solution right into one of the stock pots that I keep, and get our gold out of the bottom of this beaker. This stock pot is full of copper, and what happens in the stock pot is any traces of precious metals that are left in that solution that we just poured off will cement out on the copper that's in there. Now what we're going to do is we're going to rinse with a little hydrochloric acid. That's all right. I'm not going to worry about pouring off a lot of the gold into our waste container. I can always get it later. So now we'll pour this waste off into the waste container. See, there's lots of gold going over with it, but that is quite all right. With the bulk of our gold is left up here in our beaker. Now what we'll do is rinse this out with a little water. Now it's just a matter of rinsing it over and over with water and hydrochloric acid until I get all of the ferrous sulfate rinsed off out of it. I'll be able to tell that when the color of the rinses is colorless. Just wanted to show how deceiving this liquid can be. It looks just like we've got gold in solution, but if you test it with Stannous chloride, there's nothing. The ferrous sulfate looks just like gold in solution, but as you can see by that Stannous test, there is no gold in this solution. Alright, I've used up a whole bottle here of space for waste. Now I want to demonstrate why we use hydrochloric acid to rinse our gold off. I just added some distilled water. You'll notice that water appears colorless. I pour this off now. It's got a little bit of a tint of yellow to it. But then when we add some hydrochloric acid, it blooms into a bright yellow color that we don't get with just water. And we want to keep rinsing this off until all that yellow color disappears. Well, this is one of the downsides of using ferrous sulfate. It takes a lot of liquid to rinse all of it off of our gold. I've used over a gallon of hydrochloric acid to get all the yellow color out of it. And then I used a couple gallons of hot distilled water, and I rinsed it over and over. Alright, now what we want to do is I'm going to transfer the gold into this this dish here, and we're going to dry this off into a nice fine powder. Carefully get it into this dish. Wow, I can see purple. Purple is the color of gold, but it's colloidal gold. Very, very fine particles of pure gold. Alright, I'm going to add some heat. We're going to slowly dry the gold powder out. The reason we spent all the time, about 2 hours, rinsing with hydrochloric acid and then with hot distilled water is because I want to make sure all of the acid gets rinsed off of this gold. We're going to be offering it for sale on my eBay site. Here I've got a pH test strip, and you can see by that color of that test strip, we've got all the acid rinsed off of the gold. Here's our final products. I've got the gold bar. We've got our gold powder here. I've got the weight of the dish on the side. So we've got 520.4 minus 399.7 equals, so we got 120.7 grams of pure gold in here. And then we've got plus 148.2 equals, so now we've got a total of 268.9 grams from this refining. What we'll do is offer the gold powder that we have here for sale in my eBay site, and I'll put a link in the description of this video for the gold powder. We'll sell it by the gram. And this will conclude the video. I'd like to thank everyone for watching and wish everyone a good evening.